Okay, everybody, let's get started today. So thank you all for joining us. This is the Unified Equipment Interaction Management Project, our end of project webinar for Tuesday morning here in the US. We have most of the project team here today with us. I do want to let everybody know that you are on mute. And if you do have any questions during the session, I would ask you to please type them into the chat window. We will gather those questions and ask them of the team at the end of the presentation. This presentation, as well as the project paper and one of the recordings, either this morning's recordings or the recording from this evening, whichever one we get that is the cleanest, will be posted online, and we will send a note out to all the folks that registered to have access to that. I will also drop into the chat window the link to where the paper is. The paper was published this morning, so I'll put that in the chat window for those of you that are interested as well. But in the meantime, what I want to do is turn this over to the project chair, Natal Patel from Intel, who will take us through this and give you an overview of the work that we've been doing here for the past year. So Natal?
Thanks, Mark. I'll go ahead and share from my screen.
Go right ahead. I'll cancel my share. Thank you very much.
Let's see this,
No worries. Perfect.
Okay. So this is a project, as Mark mentioned, around trying to standardize and hopefully improve data collection on the factory floor, as well as to improve the efficiency of operators and what we do on the floor. And so I'll start with the background. We'll go over why we wanted to do this and what were the objectives, the goals of the project. What did we look at in terms of options to implement what we were proposing? And then finally, what we documented and sent in for the semi-standard task force. I think we kind of realized that anything in this space had to be standardized across all the suppliers and manufacturers versus doing a one-to-one development. And part of the project team also did specific proof of concepts to understand if the proposals were implementable, and the analysis was done and also used as feedback to SEMI to incorporate into their standard activity. And then we will just conclude and look at the next steps. So list of project participants and organizations. We basically had 5 companies. I think myself from Intel, I think Ryan, who's on the bridge, he was our lead into SEMI, as he is the co-chair of the Standards Task Force. Delbert, who also works at Intel, was part of the POC activity. And then we have RC from Symetrics, Jürgen from BESI, Bart from KNS, and then Yao from Critical Manufacturing, which is part of ASMPT. I'd like to thank them all for their contributions to this project. So background. So traditionally, when we talk about smart manufacturing, we talk about looking at sensor data, looking at process control, fault detection, yield. But this project is a little bit different. So what we've been looking at in this project is how can we make use of digitization to improve the efficiency of people on the factory floor, help with downtime reduction, and make the operations and repair procedures more efficient by collecting more data and information off the tools. And also, I think one aspect that came up from the equipment supplier side, that something like this would potentially help them troubleshoot equipment remotely, as well as help them streamline the equipment software and the user experience. And I think that was done as part of one of the POCs as well. So the problem that we are facing today is if you look at the bottom left figure, based on the recommendations from the from SEMI and also from I think it's the Princeton architecture, the factory systems are typically separated from the enterprise via firewall. And what this does is this limits the communication that equipment has with the enterprise systems. And due to security, and given the fact that some of these tools could be running the software for years, We have them isolated, and they communicate basically with a factory host, and the factory host is then responsible for communicating with the factory systems and to the enterprise. So what this does is essentially drives you to either have local accounts on the computers on the tools, or sometimes people leave the computers completely unlocked, right, depending on the factory. So if I look at a link tool, for example, on the bottom right, it's got 6 subtools. Could be basically a reflow process, and you have the factory host which communicates with this link, and you essentially end up in a situation where if you were to enforce security on everything and accounts, you end up with about 7 different accounts, which is, as folks know, is completely unmanageable on the floor. So what typically happens is, you have essentially generic user accounts, and these links would be, it's not just one link. You could have, 4 or 5 of these links based on your capacity requirements. So the whole area basically runs on, one set of generic accounts, and it's very difficult to, figure out who's accessing the tool, who did what on the tool, and besides security, it just makes data tracking and collection extremely difficult. So this is the problem that we're tackling was, how do we get into a situation where we can secure the tools, all this equipment, make it easy for the operators to log in, log out, get them the right level of access, and also be able to understand what are they doing. Is the is the response flow checklist or the PM checklist correct, or do we have gaps, and so on, and collect more data on how people are interacting. So, like I was mentioning, why is this a problem? So for manufacturers, basically we have lack of security on the equipment interface side. We don't have a way to authenticate and do any role-based authorization. We don't know who's logging on, and we don't even are logging on at the right level. It's very difficult to make out. There's also a lack of traceability on what was done on the interface. So what parameters were updated, what alarms, what was done to clear an alarm. Did they teach or follow the correct steps for teaching? If they were teaching, for example, a fiducial on the substrate. And the idea is to identify, training gaps. So, is the training correct and complete? Do we have the correct documentation for them to follow so that we can help them improve the time it takes to resolve issues? And in the future, I think there's also an opportunity to leverage RFID and other non-keyboard means. So you can, if you're using badge scanning or some other token to in your factories to log in using, for example, single sign-on, there's opportunity to enable single sign-on on all the tools so that the operator is logging on with the same credentials on all computers in the factory. The tool suppliers, basically, right now there's no insight into what software features are of interest, how are users using the software or the interfaces, what software is not required or not being used at all. So there's opportunity to optimize workflows, usability, overall streamline the software and prevent software bloat. So if you look at what we're proposing, for the list on this side, on the left side is today's situation, where everything is locally managed. Passwords and user IDs are typically shared. No traceability, no way to audit who has access and at what level do they have access. You cannot enforce training, so you can't lock a user out if they have not had their training at the right level. And then there's no way to hold anybody accountable in terms of alarm clearance, and also hard to figure out what was done. So what we're proposing is when we move to something like an enterprise role, enterprise managed access, you can basically start using your standard enterprise credentials. Everybody has their own unique credentials at the enterprise level. We can trace who's logging in, who did what on the equipment. We can assign roles to people so that when they log in, they automatically get the right level of access. And also, since you're managing this on a role-based basis, you can audit and see who has access at what levels, and if people change jobs, you can disable the role or then move them to a different role, and log all the actions that the users are taking, right? So I think the key questions were, is the person authorized to access the equipment? Do they have the correct level of access? And what did they do with this? So I think what we realized was that anything we did would have to be driven by a standard. And this was really a little bit over a year long worth of activity. So we engaged with the SEMI cybersecurity task force, and that's, we basically pulled in Ryan, who's the chair of that task force. And this ballot was submitted to the task force. And what we were doing from the project perspective was to first review what was being submitted and look at the options. We gave feedback in terms of what we thought were the correct wording and the correct structure that we would need these standards to be in. We spent about 2 quarters doing pilots, and at the end of the pilots, we basically gave the final feedback to SEMI this early. I think it was late in December, and I think we're just wrapping up the project this quarter. Okay, so I'll just go through the three design options we looked at, and then also what was the final one that was sent in before I turn it over to Ryan to discuss to give you the background on the SEMI task force. So all options we look at, there will be a local user on the computer. I think this was some very strong feedback we got from all companies, especially when you have a first of a kind piece of equipment, or you want to handle non use cases, or if you're doing some development work, you may want to be in local mode. And so there'll be a super user account on the computer. And option one was, that we would have the factory systems push the credentials to the equipment, so they would keep all the user ID, passwords, roles, and so on locally on the equipment computer. And they could, you could locally validate access just at the computer itself. So the advantage of this was that, if the network goes down, you can still have access to the equipment. But the disadvantage is that you have to continuously keep pulling the enterprise systems, keep pushing credentials, and it wasn't very clear on how we would filter the right credentials for the right piece of equipment, and it would make this pretty unscalable when you're looking at 1,000 tools in a typical factory. And the likelihood of the network being down is pretty slim. In most production use cases, if the network goes down, you would also have other problems to deal with. So the other option was to use the factory host to do the authentication. So the factory host already has communication with enterprise systems. Typically, you would be using your enterprise credentials to log into the factory host. But the issue with this is that if the factory host is unavailable, then again you have a problem accessing the equipment. So if you were doing some repair work or doing some PM activity on the equipment, if the factory host is also having it being upgraded or downgraded, being upgraded or replaced, or in any state of unavailability, you would be unable to access the user interfaces on the tool. But if you look at this flow, it's basically if I'm using, for example, an RFID scan to log in, I send this data over to the factory host. It checks with the enterprise system, gets back the roles, and it sends the filtered list to the tool, right? So this concept of, when we're looking at this use case, this concept of filtering came about. We didn't really want the equipment to know all the roles a user had, because there could be other roles tied to non-production access, and some of the roles contain IP information as well. So I think this idea actually percolated over to the final recommendation, where we decided that instead of sending the list to the equipment, we would just send the equipment will actually ask and see if the user had access at the right level. And that's this final design that was submitted as part of the SEMI ballot, where the key thing is that when the user requests an access, there's a factory level authenticator that is bridging the networks. So you have the factory network on the left side, the enterprise network on the right side. And what this is doing is the tool would send it a list of configured roles that are defined on the equipment. So if I'm on a specific tool type, I might have a set of roles tied to that specific tool type, and those configured roles are sent to the authenticator, and this in turn checks with the enterprise network, gets back all the user roles, and all it does is it sends back a yes and no to each of the configured roles that were sent by the equipment. So if the user has any configured role, then the login is permitted. If there are no configured roles for that user on the enterprise side, then the equipment will not unlock the screen and will not let the user access the UI. Once the configured roles come back, then the equipment has to sort through them and allow access to the right level, and then you basically log all the user activity. And you can also have an idle timeout, which is part of the standards recommendation, that if the user is not doing anything for a specific period of time, which will be configurable by they would get logged out. And all the activity that they did during this time is then saved off. It can be either pushed to a filer or the factory host can query and retrieve it. So what this does is it basically gives you a unified solution, that where we basically expect standard behavior from every equipment in terms of how they are going to interact with this factory component. And since this is a factory component, it can be made redundant with high availability. You can have failover and other hardening tied to it. And this is also compatible with single sign-on solutions. So typically the way SSO works, it is through a token that gets sent back. And then this is kind of a similar solution, so it should be compatible with single sign-on. The disadvantage is that, of course, you'll have to configure the user roles on the computer, so on the equipment. So for every piece of equipment you have, you'll have to go and say, okay, here is level 1 access, level 2 access, level 3 access, and map it to specific jobs and roles. And there's I think in the white paper, there is a proposal that, even that could be made, the configuration could be stored off externally and just pushed to tools for a given, tool type. And this was a preferred solution that was included as part of the task force standards activity. So Ryan, I think I'll turn it over to you to discuss the task force background.
All right, thank you. So yeah, my name is Ryan Bond with Intel Corporation. I deal mainly with Intel's participation within the Information Controls Committee of the Semi-Standards Organization. So in 2018, we created the North America Computer and Device Security Task Force to address the need for cybersecurity standards in the semiconductor manufacturing. And this was very much in part due to the WannaCry and some of the other ransomware and so forth that hit major device manufacturers and caused significant impacts to production. Since then, we've published E188, which is malware-free equipment integration, expanding on requirements that were published in E187, which is a cybersecurity for fab equipment. So there is another a joint task force in the Taiwan committee that is also driving these standards forward. And so E187 was published by the Taiwan group, and E188 was published by the North America group. Since then, we began drafting a new standard for equipment access management and monitoring in 2022. And so this process that you're seeing in there is the result of that the information gathering and proof of concept phase of that standard development. Next slide.
Did not refresh.
Oh, there it is. So some of the sample feedback that we've gotten as part of this this process. Originally, we had a requirement for authentication authorization mechanisms shall not require access to an external network during operations. We found during the proof of concepts that this requirement was detrimental to many implementations. So we're in the process of revising that requirement to recommend that essential functions of the equipment should be maintained if the fab network goes into what we're calling island mode, where it isolates itself from the external network during an expected attack.
I think thanks, Ryan. I think Delbert, you can talk
Thank
to
you.
the intent.
All right, thanks. Hey everyone, I'm Delbert Gago with Intel Corporation, and so I'll go through the proof of concept that we enabled at Intel. So the key elements of our POC was the access control, the authentication and authorization with the enterprise systems, the roles rights management, configurable access management, as well as logging of user actions and the activity timeouts. So on the diagram on the left, you'll see the roles and rights management. So what we did is we have the user is mapped to a specific role, and the role is then mapped to an enterprise group. So the enterprise group belongs to our enterprise systems. And within the enterprise group, you can have multiple subgroups, as well as users within that subgroup, and then multiple users within that enterprise group. Now from the role, this is then mapped to multiple rights, and rights are configured for viewing individual pages, as well as interacting and controlling those pages. So we had two different rights, which was a view mode or a control mode. What this allows us to do with the roles and rights management is we can configure this at the equipment level. It's also flexible, so you can add different enterprise groups and map those to specific roles. You can also take this configuration and apply it to multiple test equipment or modules. And the other key feature was the vendors do not need to know about the enterprise group. So if the enterprise groups contains any sensitive information in the group name, this can be configured at the tool level. Okay, yeah. Some of the other items we highlighted was the access control. So users, before logging into and interacting with the equipment, they need to pass in their username and password. And so this hits the authentication system. Once authenticated, then we check and see if they are authorized for any of those specific roles. So this iterates through the different roles that are configured on the module, and if they belong to that group, then we pass back yes, and they are authorized for that specific role. So all of this is then logged into our equipment, where any of the user actions are logged, as well as when anyone tries to authenticate, it's also logged. The last section was the inactivity timeout. So part of the ballot was enabling an inactivity timeout, where if there was no interaction on the tool, it would log them out after 5 minutes. So we made this configurable where you can adjust it, but we set it to a default of 5 minutes.
Thanks.
All right. Thanks.
Right, I think, yeah, we want to talk to slide.
Yeah, sure. So hello, I'm Juan Cortez. I'm with Critical Manufacturing, which is a part of SMPT. So on the left, you have the user rights configuration, which currently it's only done at the equipment level. You have different users, which you can assign to a single predefined role. So there's a set of predefined roles like admin, developer, operator, and a user can only belong to one role. And then you can configure permissions to the different roles. So the POC consisted in extending this mechanism to support the proposed user login and authentication method. So the change was that if a user includes a domain prefix in the username, it's considered an enterprise user. And the roles, you have the option to map to an enterprise role so that the system can recognize that the role it's from the enterprise. So very important, we have to support backward compatibility. So legacy users, they will continue to work as they were. So whenever the user tries to log into the equipment, if it does not have the domain prefix, it's authenticated using the legacy mechanism. And then the system resolves the user to the role that the user is assigned. If the user has this domain prefix, the system assumes that this is an enterprise user, and it will try to authenticate user against the enterprise directory services. So the enterprise directory services need to request what is the information that it needs. typically username and password, but could be a token or other type of biometric type of authentication. And the user needs to provide the necessary authentication information. And in case the authentication is successful, the equipment man needs to query enterprise services to which equipment configured enterprise roles the user belongs to. It could be the case that the user belongs to multiple enterprise roles that are defined with equipment, but because the system can only support one user, one role, there's a convention that the system will try to map the user to the enterprise role with the highest level of privileges. So there must be a way of sorting the equipment roles by some type of hierarchy. And this is the way that the system assigns the user to a single enterprise role. And then it continues normally as the legacy system.
Thanks, Joe. Me. So I think Bart could not make it for the KNS POC, but I think what KNS focused on was primarily on the logging. So I think they did a lot of work on identification of all the buttons and all the tabs and so on the user interfaces that they needed to track, including tabs that had teaching as part of the activity. And I think one thing that the feedback I got from Bart was I think they did implement this. They were able to see considerable gain in diagnostic time because the key thing was that the users thought they did something, but it wasn't exactly what they did in some sense, because it all happens after the fact. Something gets, your tool has an alarm, and then they escalate, and they may or may not remember exactly what they did. So the data that they were collecting helped them replay exactly what happened. In addition to that, with the time zone differences between where if the field support engineers are and the corporate developers are, it greatly reduced the time to pass data back and forth. So that the folks, the developers in the central group could pull the logs, pull the data. Didn't have to wait for the FSC to tell them what happened, and you have that the time lag between time zones. And it led to much faster resolution on some of the issues that they were seeing on the tool, and it reduced, like he's saying, reduced the back and forth communication because all the data was there in the equipment logs. So I think anyway, so next steps, I think we concluded the project. We evaluated all the options. We did the pilot. We gave the feedback to the SEMI task force. I think per what Ryan has indicated, there'll be a series of ballots this year. And we are hoping that something would be standardized or come as a standard by end of the year or by Q1 of next year. Again, there's no guarantee on that because the SEMI process might go through multiple ballots. But hopefully by 2025, we should have something that we can incorporate as part of standards that we incorporate. That is pretty much it. Thank you for attending.
Yeah, thank you, Natal. Thank you, team. Appreciate it. If you want to go to the next slide, I think it has the contact information for folks. Let me, for those that are interested, I will put into the chat link to the paper again, and also to the project page that's up there on the screen. For those that want quick access, you can get into it through the chat. I would ask now if there are any questions from anybody. I do have a few that I captured during the session to ask, but let me give the current audience a chance. If you've got a question, you can use the raised hand function or type it into the chat window. Otherwise, I will move to some of the questions that I got directly. So why don't I begin with a couple of questions, and then we'll see if anybody else asks. So there was a mention, I think somewhere in your presentation, Natal, you mentioned operational efficiency gains. Do you have any estimates as to what that would be like when this is implemented?
So I think from internal checking that I did within, like within Intel, it looks like, we're expecting about 30 to 50% reduction in, for example, time between assists is a good example, right? So if we can respond correctly to an assist alarm, what I'm hearing from our factories is that they see a considerable opportunity to reduce the or extend the time, I would say, not reduce, they extend the time between assists. So they're expecting it to about, the number of assists to go down by about 30 to 50% per, within a given, like, let's say per hour.
Okay.
And most of it is due to, basically making sure that people are following the procedures and not just kind of trying to get the tool back up and running as quickly as possible without doing all the due diligence that they need to get done, that needs to be done.
Okay. There was a question for Delbert around, basically said, after the user information is logged, how is it used? Or are you looking at merging it with equipment history? So they're
Yeah, so we have a centralized logging system within our factories, factories. And so what we're doing is we're going to leverage those logs on the equipment and combine that into our centralized logging platform. And so now we can analyze the logs from the user interactions, tie that into what's happening on the module. So if there was a particular failure on the tool, we can trace that back to a user either performed a RFC incorrectly, or see what was the behavior of that module. But now all of those logs would be interacted or integrated into that centralized logging infrastructure.
okay. I saw two questions related to kind of the standard and semi. So Ryan, high level is how long do the have the semi ballot cycles taken in the past to get through? I know you showed this iterative screen here before up to 2025. Is that
So
what we should expect or not?
from ideation to publication was about 4 years for the E188 and 187. I'm hoping to get this done in in 2 or 2.5 would be a a big improvement in my mind. But we typically see about 3 revisions. Usually tends to get a lot of you get above a 50-50 shot at that point. But we've definitely seen them go to 4, 5, and 6 pretty easily. So we'll just submit and address the feedback as they come through, and be prepared for the just to drive through the cycle process.
Okay, and then sort of the follow-on question is, what are the next steps, I guess, for industry or for anybody once the standard is actually ratified? This is might be for Ryan, might be for Natal. I'm not sure.
Once the standard is published, it'll be available to any members of SEMI through the semi.org website, and at that point, it'll be really up to device manufacturers, as always, to make this a requirement for their equipment, and then to drive those requirements with their suppliers.
Okay. Are there any other questions or comments from either the attendees or the team? So Grace, do you have any parting words as a vice president here of iNEMI or for the team?
No, let me just say, I think congratulations to the team on completing this. And I think what's really good to see is the engagement with SEMI, the Standards Development Organization, and I think helping the development of the standard and the faster development of robust standards is very important for the industry. So it's one of the objectives of the iNEMI projects to look for opportunities to do that. So I think this has been a good one. Yeah. Hopefully we'll have other opportunities in the future.
Great. So I will last call for comments or questions. We will make the, go ahead.
Well, I just wanted to thank the team. I think we did I think it was a pretty short project, quite intense, and hopefully this will help make life for people on the floor a lot easier, and maybe the manufacturing managers happier in terms of what data they can collect and how they can improve their operations.
Absolutely. And I think we will, iNEMI, as I said, we've published the paper and we will publish this presentation and the recording here in the next week or so. When the standard is ratified, I think we'll also be able to, hopefully at that point, include a link to how to get a hold of that standard once it's done as well. And we'll make sure that we update the paper accordingly with our references. I would also like to thank the team for their hard work on it. It was heads down for a good year going through everything, and they came up with some great feedback, and I think it will make for a better standard.